All right, ladies and gentlemen, let's talk about the most important topic. This is Rush Mahaber again. That will be responsible for, I guess, the most important topic that you will use in your mathematical life, and that is literally just solving non-linear inequalities. And I'm going to begin by starting with linear inequalities, and we'll talk about the difference and how do you identify them. But moral of the story is that if you can't do this, you should not be in pre-calculus. If you can't do it effectively, don't go to pre-calculus because you're just not ready for it. The foundation of your mathematical pyramid is extremely weak, and you stack any more knowledge on that, it can come down to a crumbling failure. So, and I'm just trying to prevent you guys from having these kind of issues. So, let's just talk about nonlinear inequalities in general. Well, let's just talk about inequalities, right? Let's just start there. There's two types. There's two types. Okay? And those types are linear and nonlinear. And nonlinear is easy, but let's talk about linear for a second. And I'm going to ask you to solve something. Here's a linear guy. Can you solve that guy? And everyone's probably saying yes, but let's talk about why it's called linear. It's called linear because the degree of the polynomial is 1. That's the first thing. Okay, it's called linear because if let me explode this a little bit. It's called linear because if we were to look at this as a function, which is what we're getting ready to do in 1800, and we call this our function, that would be considered a linear function. Okay, so if I ask you to solve this, let's just solve it. And I'm not going to go through and erase this because I'm going to need this in a second. But if you solve it, this is what you would do. 2x is greater than negative 4. X is greater than negative 2. Everybody would agree with me that this is the right answer. And then I'm going to ask you, why is this the answer? Why does that even make sense? I don't even know why it's the answer. Like, what does this even tell me? And everyone's saying all the numbers greater than negative 2. But what do all the numbers greater than negative 2 do? It satisfies this inequality. But now let's look at this from that's a remedial algebra, basic algebra, advanced algebra perspective. Let's look at it from a pre-calculus perspective. We solve inequalities because they describe graphs. He's called linear because if you were to graph him, don't write this down. I'm just trying to give you an understanding. We should know how to graph this. This is a straight line. 1, 2, 3, 4, y-intercept, and it does this. This thing is asking me, when is this line greater than 0? We're greater than 0, so when is the function, the y, this thing, y, greater than 0? It's greater than 0 here. That only happens when it's above the x-axis. This is what you've actually been doing the entire time when you were solving inequalities. Anybody want to guess what that number is? It's negative 2. So all the x values, so this is what we're trying to solve for. All the x values, that gives me a y value that's above the x-axis. What it means by when we say greater than 0, 1 above the x-axis. So this is an advanced understanding of what you've already been doing. Okay, so why can't we do this for everything else? So straight lines, it makes sense because once it cuts the x-axis, it just keeps going up. It's never coming back down. It just keeps going up, and it makes good sense. But could I solve this directly for something different? So for example, let me change my colors back. Could I do this for this? Right? Is this guy linear? No, it's degree 2, which means it's nonlinear. Okay, meaning it's not a straight line. You guys should all know what this looks like, and I'm going to spare you the details. It is a parabola of degree. It's a parabola, and it opens upward, as you guys should pretty much already know. And this is what I'm going to tell you because I know how the graph looks. Okay. Now you remember, most of the stuff we're going to do, you're not going to know what the graph looks like. But this is what we're doing. We're solving this stuff, right? These inequalities. Now this is why I see a lot of people do this, and this is the game over. You lose. And then the minute you do this, you lost. Game over. There's nothing left to be said. It's a terrible problem at this point because what are you claiming? That the only way these two things multiply together can give you something bigger than 0, which is positive, is if both this thing is positive and this thing is positive. Not true. They could both be negative, and that'll also give you a positive. So you've cut out half your solutions, which totally trumps everything. So you get this. So you'd actually end up saying this thing. And now note, this is epically wrong. This is not even kind of wrong. This is epically wrong. This is what your answer should be. And because I know what the picture is, I'm going to draw the picture so you can see it. It's going to look like this. Here's -4. Here's 1. These are the two x-intercepts. And it does something like this. Okay, because it's a parabola. It should cut through the two x-intercepts. I already know this. I don't know what the vertex is, but I know this. They're asking me when this thing is greater than 0, and I know greater than 0 is above the y-axis. So my answer is going to be here, which means I'm looking for all the x values that does this. That's going to be -infinity to 4 and 1 to infinity. I can already tell you that's what the answers are going to be. Now, I can do this because I know tons of mathematics. If you don't know tons of mathematics, then you can't do this. Right? So that's my answer. I can tell you that off rip. Okay, and don't worry, you will after this class, especially after we get done talking about a whole bunch of stuff. So what do we do? Because this is garbage. This is garbage. Okay? That's why we categorize this as linear and nonlinear inequalities. Nonlinear, caution. You do anything like it's an equation, split it up into two things when it's an equality, game over, you lose. You don't want to do that. So what do we have to do? There's a method, it's called the sign chart. We must make one. Okay, and what does the sign chart do? It basically tells you this. It tells you when on what intervals of the x-axis is it positive, negative, and is it positive. You didn't know that, but that's really what you were doing when you were making the sign chart in the previous course. So let's restart the problem. Here we go, and you get x squared plus 3x minus 4 is greater than 0. I already drew the graph, but keep this in your head. Keep this to the side. Don't even do it. Let's consider this a clean problem. You don't know what it looks like, okay? But based off the graph, you already know what the answer should be. So we got to make sure that our stuff matches up. So first things first, we do a sign chart on the function. So you see this inequality? You don't need it. Get rid of it. Let's just look at the function. Let f of x equal this thing. So we're going to do this. Let's make a sign chart. Sign chart on f of x. And then once you make the sign chart, then if they say where is it greater than 0, we'll give them all the positive stuff. If they say where is it less than 0, we'll give them all the negative stuff. If they say where is it equal to 0, we can give them where the zeros are at. You know, we can give them a lot of stuff all based off the sign chart. So let's do it. Okay, so how do we make a sign chart? We first got to figure out what these zeros are and what the undefineds are. And yes, undefined are exactly what you think they are. Okay, zeros are the numbers that make the function equal to 0. I'll put that in parentheses. So for my function, that's when it is x squared plus 3x minus 4 equal to 0. Notice there's no inequality anywhere. I said throw away the inequality. We're not even looking at it. It's true. We're looking at these little boundary points. When you get to calculus, they'll call them critical numbers, right? And inflection points, like they have bigger purpose. So not even looking at the inequality. When we get to the end, we'll look at the inequality. So x plus 4, x minus 1 equals 0. So my two zeros are -4 and x equals 1. Undefineds. Undefineds happen the same way if you have a denominator, right? If there's a number that can make the denominator 0, then we can't have it. It crashes our system. So do we have a denominator? So can f of x ever be undefined? Well, there's no denominator, so I don't have none in this case. Could I have some? Potentially, yes. And if I do, I'll never include them. Never, ever, 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 ever include them because you can never divide by 0. So if a number can make the denominator 0, he has to go. Has to go. That's the moral of the story. So maybe I'll put that in a nice little think bubble here. Never include these in solution, because it means you're letting stuff through that might break your function. So now what do you do? So this is the first step, naming your function. Second step, third step, finding your zeros and your undefineds. And fourth step, we're going to make our sign chart. All right, here it comes. Here it comes. Draw a number line. Boom. Now, anything that's on this number line is good to go. So what is going to go here is your zeros and your undefined. So the two numbers is -4 and 1. And you need to label these. Put a Z here and put a Z here. I know some people have seen people shade stuff in on the number line. the sign chart is made for the function. You're going to use them to graph these functions when you get to later on in pre-calculus, and they're going to have other things. They're not just for solving linear inequalities. That's why I said forget the inequality. Let's just look at the function, because that's how it's going to be applied to everything else. But eventually, you will use it for all that stuff. So it's not just for inequalities, it's also for inequalities. Okay, it's also. So this is something that this is how you should be doing it for everything. Zeros labeled, undefined labeled. Okay, now you notice it created 3 intervals. You need to test these intervals. So plug in a number. Where do we want to plug it into? Well, that's why we called it a function, ladies and gentlemen. We called it a function, so you know what to plug it into. So here we go. And because I'm trying to keep all this on the same screen, I'm going to write it right here. So I need to figure out what f of, give me a number over here. I'm going to do -5. F of 0 for the middle guy. Boom. So this is the first quadrant, the second quadrant interval, the third interval, and then finally f of 2. All right, let's go. I hope you guys can do mental math because I'm doing mine. And don't worry, later on I'll show you some cool stuff with a word called multiplicity, where once you find out 1, all the rest of them are easy. So you plug in 0, you end up getting out -4 here. You plug in -5 is 25 minus 15 is 10 minus 4 is 6. And then you plug in 2 is 4 plus 12 is, oh my god, I can't count, 12. All right, we're all done. Okay, so what does this tell me? That this is positive numbers, this is negative numbers, and this is positive numbers. And now, once we've created our sign chart, finally, after doing all this mumbo jumbo, then finally we can do this, which is 5, give them an answer. Now you're probably saying to yourself, well, what's the answer? Well, the answer to the inequality. That was the original question. All of this stuff, all this work we did, pertained to the function. Now we can answer their question. They want everything that's bigger than 0. Bigger than 0 means positive, which means that I want all this crap in here. So I want everything from -infinity to -4. Now, do I want to include -4? -4 is a 0. The answer, no, because I want to be strictly greater than 0. Had it look like this, which is being equal to, then I would include it. I'd put a hard bracket there, but it's not. It looks like that. Strictly greater than. So I'm just going to go up until 4. Boom. And then I don't want anything that's less than 0. That'd be this negative stuff, right? Now, if that sign, now here's a cool thing. That's why I said the inequality doesn't matter. Because if the inequality was this, we'd just be looking at this middle part where it's less than 0. Wouldn't even be looking at the outside parts. And then finally, I want this interval, which is 1 to infinity. And unity together. That's my answer. Now, the work matches up. Everything is pretty clear on how it happens. And notice, that's exactly what we had when we did our initial graph. Okay, so notice that there's a bigger story to this than what's always been told to you, especially when you're at the level that you guys are at. So we have to keep pushing through it. Okay, keep pushing through it. Now, a couple things. Let's talk about a more complex one. So let's just do a rundown of it. Number 1, forget the inequality and label your function. Number 2, figure out when the function is equal to 0. Figure out when the function, what numbers make the function blow up and make them undefined, which means what numbers make a denominator equal to 0. In this case, we had none because there was no denominators. Then plot your things that are on your zeros and undefineds on your sign chart. Test the intervals with random numbers. Where do you test them? In the function. That's why we named them. And then finally, give the answer of what we need to give, whether it be greater than or less than 0 or equal to 0. It's really that simple. Okay. Let me draw something that we don't have the muscle to graph. Okay, we don't have the muscle to graph. So here we go. How about this one? Solve. Okay, I want you to solve this. X squared minus 1 over x squared minus 9. I want you to figure out when this thing is less than or equal to 0. So once again, first things first. Do I care about the less than or equal to 0 right now? Answer: no. First thing you need to say is let the function equal x squared minus 1 over x squared minus 9. Done. And this is all I'm going to look at. I'm not going to come back to this until the very end. Okay? Now what do I need to find? I need to figure out what the zeros are, which basically means when is my function equal to 0. And then what my denominators are. Oh, excuse me, what my undefined. Depending on who you had, they might have called them bad guys. or undefined or domain restrictions. Like, they're all the same thing. You just got to get accustomed to whoever's teaching you. So this one makes the denominator equal to 0. So here we go. Set my function equal to 0. Oh, look, I should probably clear my fraction. Boom, gone. Gives me x squared minus 1 equals 0, so x equals plus or minus 1. We'll get to the point when I start doing these videos where I won't even show you the work. I'm just going to give you the zeros. Done. Undefined here, well, that thing can't equal 0, so x cannot be plus or minus 3. Pretty simple, right? So, like, think about it. The work is quick once you know where everything is. So, labeled my function, zeros, undefined. Now, finally, let's make my sign chart. Here we go. Everything that's here that's on your zeros and your undefineds need to be on your sign chart. So please make sure you label everything and put them in the right order. It's -3, the -1 comes next, then 1, and then 3. That means, and what's what? This is a undefined, this is an undefined, this is a 0, this is 0. Here's a snapshot of the future. When we graph these, you'll soon realize that undefineds are vertical asymptotes. I know it's a freaky word. And zeros, we won't call them zeros anymore. We'll call them x-intercepts. Freaky, freaky. All right. Nope, we don't have a graph to go off of this time, so our sign chart is the only way to figuring out the answers. Now, here we go. What do I do now? I have 1, 2, 3, 4, and 5 intervals. Now, let's test all 5 intervals. Where do we test them? In the beginning. Now, here's a little trick of the trade. Do these problems always factor? No. Sometimes you might need to use quadratic formula. I tell you what, though, it's easier for me to multiply stuff together than it is to divide, than it is to add and subtract. So you'll see some people, they'll factor it out and then just plug it into that one. Either or is fine, as long as you're sure that these two are equivalent. If you by any chance bust yourself open by not having the correct factors, then game over, you lose. Okay, so in quadrant 1, I'm going to plug in -4, quadrant 2, quadrant interval 2, I'll plug in -2. And yes, if this was a -2, then you have to plug in a -1.5 here. Don't think you're off the hook, because there's still an infinite amount of numbers in between any two numbers. 0, the magic number, 4. Okay, and here's a cool trick. They call it the sign chart for a reason. Why do they call it the sign chart? They call it the sign chart because we're really just after the sign. We're after when they're positive, when they're negative. Okay, so I'm going to do the easy one, and I'm going to give you the signs, and then I'm going to let you figure it out. Okay, here we go. If we plug in 0 into my function, the one that I have labeled here, I end up getting a -1 on top, and I end up getting a -9 on the bottom, so I end up getting a positive. And I'm going to guarantee you that it'll be this. Now, do I know this for sure? Yes. Why do I know this for sure? Because I've done a cajillion of these problems and I know some other math stuff, okay? You should be plugging in the numbers to figure out what it is. Now, will it always go plus, minus, plus, minus, plus, minus? No. It might go plus, plus, minus, plus, minus. You know, you got to be careful, okay? So this is positive. It's negative, positive, negative, positive. All right, so here we go. We did all this just to give them what they want. They want to know when it is, and I'm going to color some stuff in so you get it, okay? They want to know when it's equal to 0. So where's it equal to 0? That's this number and this number. Are these numbers equal to 0? No, they make it undefined. You'll never include this, and you'll never include that. Real simple. Now, what else do they want? They want to know when it is less than 0. What numbers are less than 0? Positive or negative numbers? Everyone should have said negative, so the answers that they want are these ones and these ones. So your answer, let me make these bigger so it looks a little better. Your answer to this is literally going to be, so the answer is -3, soft bracket, not including that, to -1, hard bracket, union, hard bracket, 1 to 3. And we're ready to rock and roll. Once again, you clear fractions, okay, and this is something I'm seeing a lot of people love. And all right, so let's talk about a quick caution. This is the answer to this, but I want to go back to the beginning. And I see a lot of people doing this right here, right here. And I'll see this, caution, caution, all right, caution, caution, caution. I'll see this. People say, oh, it's like an equation, so multiply this on both sides. And they'll do this. And then this is where I put -10, game over. Why is this bad? Why is this awful? Inequalities. If you multiply both sides by a positive number, it stays the same. If you multiply both sides by a negative number, it flips. So this could be a greater than equal to sign. Question, is x squared, we multiply this on both sides, is x squared minus 9 positive or negative? Correct answer, what is it, positive or negative? Answer, it depends. It depends on what x is. So we don't know the value of x, and because we don't know the value of x, we can't multiply it on both sides because we don't know whether or not to flip the sign. So doing that kills the problem. Game over, you lose if that happens. Okay, so moral of the story, that's why we need the sign chart. The sign chart makes everything brutally clear, brutally clear. I know we're at the 20-minute mark, guys, but I'm going to throw one more here just so it's epically clear on what I'm talking about. Okay, so notice on both of our examples, we had zeros already on the right side, right? What if we don't have a zero on the right side? So let me give you one real quick, and I'll zoom through the work, and I'll make the sign chart, and life is good. Where we get 2x plus 1 over 3x is less than 5. Okay? Makes good sense, right? So, what do? Well, we still need 0 on that side. So first thing we got to do is a little bit of prep work before we go into surgery. Subtract the 5 over. I could do that all day, right? Adding and subtracting things on inequalities are cool, but multiplying and dividing, all bad news, right? So my function is going to be this blob, and you'll see a lot of people, they'll get a CD and add this together because they just want to make it nice and clean and smooth. It's totally up to you. As a matter of fact, I probably do it. So here we go. Actually, no, I won't. This is make it look different. So here are my zeros. Okay, and people say, whoa, well, whatever makes this, you're careful. So whatever makes your function equal to 0. So set f of x equal to 0. That's this entire blob. 2x plus 1 over 3x minus 5 equals 0. Now, clear the fraction. Welcome back to regular mathematics. Careful, this is this. This is still 0 here. Now, rock and roll. 2x plus 1 minus 15x equals 0. This gives me, can I add? Negative 13x equals 0. So your x is going to be, what is that going to be? 1 over 13 is what's going to be your zeros. Your undefined, well, you only got one denominator, right? Denominator can't be equal to 0. So 3x can't be equal to 0. So x can't be equal to 0. Pretty simple, right? Once again, enable my function. 0 is undefined. Notice I did not have inequality anywhere in here. This is 0. This is 1 and 1 and oh my god, that's going to be terrible to plug in a number in here. It's okay though. Good news is I know mathematics. So, by the way, this is what we would use a calculator for because we know how to do it. We just don't want to do it. You should not be using a calculator though. You should be doing it to get the practice in. I'm going to plug in -1. I'll probably plug in a number in here. I'll let you figure out what number to plug in. And I'll plug in, I don't know, 1 on this side. So what number could I plug in here? I don't know. 9 over 130. That's the same thing where I can plug in. So find a bigger denominator and figure it out. Actually, better yet, I'll let you figure out what number to put here. I'm not going to put this here because that actually is a big or a super huge number. It will work though. It will work if you do that one, but I'll let you figure it out. But I'll tell you what the signs are going to be. When you plug in a negative number into my function, let me go back up to my function. Plug in -1, you get, what do you get here? -1, it's 1/3 minus 5 is going to be a negative number. So this is negative. I can guarantee you that's going to be positive. It's going to be negative. Why? Because I know mathematics, some cool stuff in the future. This is your undefined, and this is your zeros. Now let's answer the question. I'm looking for when this thing, my function, is less than 0, strictly less than, which means I don't want, let me change some colors on you, I don't want the undefineds ever. But this case, I don't want my zeros either. Because last case, I was equal to, don't want my zeros either. And I want strictly less than, so that's all the negative stuff. Boom and boom, boom and boom. So what is my answer? The shaded region. This should be -infinity to 0, soft bracket, union 1 to 1/13, 1 and 1/13 to infinity. Then you box it in, and you have a great weekend because this is awesome. All right, guys, if you notice, things have gotten substantially more difficult. But the good news is that if it was hard, well, if it was easy, it would be in the vending machine, and everybody would have it. So let's put up or shut up time, guys. No, put in the hard work to go somewhere you've never been. You got to do some things you've never done. So push hard, and I'll see you on the next video.